I think when we first talked, Chris, you were talking about recharge and significant recharge areas, and then I got your agenda, and the topic kind of broadened, and I thought, wow, what a combo! So I can, with that kind of topic, I thought, I could ramble anywhere in this talk, and of course I do, and I will. But really, I mean, when Chris, in my head, really, what I thought I was talking about was really groundwater recharge, and that's what the main focus is. I have a couple points on wetlands and drinking water, but mostly on recharge, and I thought that's what the focus was. So just a little bit about this conservation. Hold on 2 seconds. Before this, about this, if you just go page up. About this Conservation Authorities Moraine Coalition. I worked for, just because you're probably wondering who the heck am I and where do I come from, but I'm a hydrogeologist, so groundwater person, and worked for basically 9 conservation authorities on the Oak Ridges Moraine that stretch from the Credit and Nottawasaga on the west over to the Trent River and Otonabee on the east. And we have a project that's really focused more specifically on York, Hill, Durham, and Toronto in terms of understanding groundwater in that area. So that's the background. Okay, next slide. So given you've asked a hydrogeologist to come, I like to use this quote quite a bit. People wonder what aquifers are. This is the best definition I've found so far. A mysterious, magical, and poorly defined area beneath the surface of the earth that either yields or withholds vast or lesser quantities of standing or flowing water, the quantity and or quality of which is dependent on who is describing it and how much money might be at stake. So probably in your days, been thinking this, but no one has ever articulated it as well as this fellow has. So there you have it from a hydrogeologist. So let's start off then. And I guess just in terms of groundwater recharge, I think there's a little bit of a misnomer out there in terms of what groundwater recharge is. So really, by definition, recharge is a process where water, precipitation or from streams or whatever, but moves through the unsaturated part of the subsurface to reach the water table, and it recharges the groundwater system. So when people talk about deeper aquifers getting recharge, it's really not recharge per se, it's vertical groundwater movement. Once it's within the groundwater system, it's really groundwater flow. So when you kind of hear, it's kind of a semantic thing, but it's just something to keep in mind when you're talking about recharge is really that process of moving from the surface to the water table. Another point that just to keep in mind with recharge, there's a lot of talk about recharge and a lot of focus on recharge, on measuring recharge, and it's a very tough parameter to measure. And I remember a few years ago I was talking to one of our country's best hydrogeologists, Garth Vanderkamp, who works for the National Water Research Institute in Saskatchewan. And we're talking about recharge, and about measuring recharge, and he really put an analogy to me that if you're looking at an inner tube or a flat tire and you're trying to understand the system, if you were examining that inner tube to see why it was flat, you would be taking a billion measurements, and you would say that the system, the inner tube, should be holding air. Whereas you'd have to find that one location where you have the pinprick of a hole to really understand the system. And he was likening that to recharge, that you can do 100 different measurements all over the place on your recharge rate, and you might not understand the groundwater flow system. So really the concept of recharge, I think you have to take in the context of trying to understand your groundwater flow system. And sure, measurements help, but they don't really get you to an understanding of the flow system. And that's a kind of a big theme of what we're trying to do in our project, is really try to understand the groundwater flow system. And that's, of course, what all of the source water protection teams and technical work that's ongoing across the province is supposed to be doing, is understanding groundwater flow systems so that we can make better decisions. Okay, next slide. So those are just some points in general. So I guess in terms of estimating recharge, I kind of thought about it and said there's probably three different ways that we've done it. And One was maybe until the mid-1990s, before computer groundwater flow modeling really got in vogue. And really consultants and so on, would take monthly climate data, do some quick calculations. Thornthwaite and Mather have some techniques to estimate evapotranspiration and look at some assumptions on soil moisture capacity, and they would determine based on that how much of your precipitation is actually evapotranspirating and how much is left available, the surplus, for either infiltrating or for running off into streams. And so that typically was done in any consulting report that you would see, and even still today, in many of them. But that was really the first methodology. And then we started moving to calibrated groundwater flow models, where you try to represent the groundwater system in a computer groundwater model, and you look at putting your recharge onto the ground and making sure your water levels are all consistent with what you're measuring in the field. So we've gone through a kind of a really quick era, and probably a too quick era, in my opinion, of looking at groundwater flow models. And now, with a lot of the source water protection direction that is coming forward, we're really quickly moving to integrated groundwater surface water models. And I mean, it's all great stuff, but it requires a lot of data, which we haven't been all that good about collecting and maintaining in the province. And it requires a lot of sophistication. And you know, I mean, you probably know in much of your work that we're probably running up against a bit of a capacity issue in the province in terms of delivering and doing a lot of the technical work that's required for source water protection. Anyway, so three kind of methodologies, and I'll just briefly talk to them quickly. So next slide. So this is a typical kind of thing you would see in a consulting report prior to the mid-90s, but you would get some precipitation estimates. I mean, here they're looking at two different environments, a till or a pond. Precipitation, evapotranspiration based on Thornthwaite kind of methodology, how much water is left. You would look at the area of your development or whatever piece of property you're looking at. And then you would partition it based on your soils. You'd say, well, probably 60% will run off, 40% will go in the ground. You get some numbers and you do a kind of a water budget on that. And so that's still done quite often. And your numbers are reasonable. You know that your recharge certainly can't be above your precipitation. And you kind of have some constraints on how much is evapotranspirating based on climate data and so on. So that's kind of the first methodology. And then more recently, with calibrated groundwater flow models, you would take a look at the surficial geology, and this is just some mapping from the Oak Ridges Moraine area. But you can see that the recharge, so this is the recharge that goes into the groundwater flow modeling. You see it largely reflects the surficial geology. You can see similar patterns. I mean, there's areas where, here for example, the green is halt and till soils. In this case, quite shallow and thin, overlying Oak Ridges Moraine. And so in places you see a discrepancy between what you see on the surficial soils and what you see in the groundwater flow recharge, and that's basically based on looking at in the subsurface and how thick your surficial unit might be, and is that surficial unit that's mapped at the surface really affecting or controlling your groundwater recharge. So when you're looking at groundwater flow models, you're a little bit more sophisticated. Next one. And it makes sense to look at to use the surficial geology largely to look at estimating recharge rates. I mean, this is a Newmarket till unit in the Duffins Creek watershed. A very tight, compact, clay-rich, well, sandy silt-rich till, but very little recharge goes through except for fracturing. And then, as opposed to next slide, something like this, well, on the Oak Ridges Moraine, where you would have coarse sands and gravels, you would obviously expect much more recharge to be moving through soils like that.